The slope-intercept form. Now, most of you have been working with the slope-intercept form of the equation of a line since 8th grade, and I know that you worked with a lot there. And what we're talking about is that the slope and the y-intercept of a line can be used to write and graph an equation of a line. And that equation is called the slope-intercept form using, guess what? The slope and the y-intercept to form that line. And what we're going to learn in doing this, and some things that you've already looked into, is that right here, this b, that's my y-intercept. And the y-intercept is going to be written as 0 and b. 0 being the x value. So when I am looking at the coordinate plane, the y-intercept right here, 0 and b, is going to be x is 0, because that's the origin or the value of x on the axis, and then b is whatever y value is that I'm crossing over the y-axis. So it can be written as 0b, whatever that may be. And we will look more into that here. But so as we do this, let's go ahead and identify the slope and y-intercept. Well, hopefully you recall too that m here is the slope of the equation of a line, and b is going to be my y-intercept. Now, of those, when I look at that, all I'm going to do is turn around and say, okay, m is the coefficient of my x. So when I look over here, the coefficient of my x is -1/2. So -1/2 is going to be my slope. Slope is represented most often with the variable m, especially in the equation of a line. And then my y-intercept is going to be whatever I am adding or subtracting to my equation. So my y-intercept is going to be 2/3, and if I wanted to write that as an ordered pair, that would be 0, 2/3. So identify my slope and y-intercept. There you have it. My slope is -1/2. My y-intercept is 2/3. And going down the line, looking at y equals 5x minus 2. Minus 2 is going to be my y-intercept, is going to be -2. And then again, my slope is the coefficient to my x variable, and the slope here is going to be 5. Doing the next one, c, my slope here, I have y equals 3x minus 6. 3 is going to be my slope, because that is the coefficient of x, and then my y-intercept is going to be -6 is my y-intercept. So just taking the equation and pulling the relevant factors and characteristics out of it. Writing the equation of a line. Now, when we go to write it, what we're going to do is we're just going to put it back together. And it says, what is the equation of a line with the slope of 3/2 and y-intercept of -1? Well, I know it's going to be y equals mx plus b, and I do need to substitute in. I need to find what is my variable for m, and then what is my variable or my value of b. So here my slope, they said, is going to be, my slope is going to be 3/2. So I'm going to replace m with 3/2. And my y-intercept is -1. So that is going to be -1. And when I rewrite that, I should have y equals 3/2 x minus 1. And that is my new equation of a line. Doing the same here, I'm going to have y. I'm going to have an x and a plus. I'm going to have my slope and my y-intercept. My y-intercept is going to be 7. B is going to be equal to 7. And then my y-intercept, my slope is going to be -4/5. So there we go. We have y equals -4/5 x plus 7 is going to be my new equation of a line. So in order to write the equation of a line and slope-intercept, I need to know the slope and I need to know the y-intercept. So as we write this from a graph, What do you expect the slope of the line to be from looking at the graph? Just looking at the graph, what they want to know is it going to be positive or negative? Well, I know that this slope is going to be positive as it moves from left to right and goes upward. It's going up positive, both positive y values and positive x values, so my slope is positive, whereas this line is going to positive x values but negative y values, so therefore that is going to be a negative slope. Positive times negative is negative. A positive times a positive is positive. Okay, so now what are the equations shown here? Well, I do need to have y equals mx plus b, and we know that b is going to be my y-intercept, the value of y when it crosses over the x-axis, which is going to be right there. That is my y-intercept. The line intercepts the y-axis right there, so that is b, so b is going to be equal to -2. And then I'm looking for my slope. Now, we haven't talked about points yet. I could take my 2 points here. I have 0, 2, and 2, 2, 2, comma 2, and this one is 0, comma -2. I have those 2 points. I could calculate my slope, but I could also just look at the equation. I could do some counting here, and I know that I go up 2, 1, 2, and I'm going to go right 1, so +2, +1, so I get to the next point on my slope. So it looks like my slope should be 2 over 1. So when I rewrite this equation, I should have y equals 2 over 1x minus 2, or simply y equals 2x minus 2, equation of a line. And if we were to test that slope, if my calculations there weren't correct, I could take those 2 points, and I have slope is equal to y2 minus y1 over x2 minus x1. So my slope would be, if I use this as my 1, this is my 2, I'm going to have -2 minus 2, 0 minus 2, and I'm going to have -4 over -2, which is going to give me a +2. So my calculations on my slope did turn out to be accurate. And looking here, again, doing the same with this next graph. Looking at my slope real quick, I am going down. I'm going to go down 2, -2. I'm going to go right 2, +2. So my slope is going to be rise -2 over 2, or -1. And my y-intercept, the equation of a line crosses over at 2. So that is 0, 2. So my equation of a line should be y equals mx plus b. Y equals, we said m is -1. -1x plus b is 2. Or y equals -x plus 2. There you go. We've created those 2 equations of a line. And moving on. Got a lot of stuff to do here. Let's see here. Beginning with writing an equation given 2 points. Well, we said in order to graph this equation of a line, we needed to have our slope and our y-intercept. If we're given 2 points, we may not know the slope, but we can find it out. Again, m equals y2 minus y1 over x2 minus x1. And let's see if I just go x1, y1, x2, y2, and I have -8 minus 1. And I put these in parentheses to make sure we don't lose track of the positive and negative signs. So, and then x2 is going to be 5 minus 2, and therefore I get -9 over 3, which is also equal to -3. So my slope is equal to -3. and it says, write the equation in slope-intercept form, which represents a line passing through these points. Well, if I wanted to find out what b equals here, because I don't have b, I have y equals m, negative 3x plus b, and I haven't calculated my y-intercept yet. The best way to do that, there's multiple ways to do that, and I'm trying to think what would be the best way to show, or we could end up discovering them both. But right now I have 3 variables. 1 variable, 2 variables, and 3 variables. And we can only solve for 1 variable at a time. So what I'm going to do is I'm going to take this point right here, and this is an x and a y, and I'm going to substitute them in for x and y right here, and then I'm going to solve for b. And in doing so, I'm going to have b here, and let's see here. So x is going to be 2 times negative 3 is equal to my y value, which is 1. And this is going to be negative 6. 1 equals negative 6 plus b. Go ahead and isolate b, add 6 to both sides. And b, therefore, is going to equal 7. So I can do that substitution right here, and I know that y is equal to negative 3x plus 7. And there is my equation of a line. Doing the same thing over on the other side, I'm going to have m is equal to, let's just go x1, y1, x2, y2. It doesn't matter which one of these you designate as 1 and 2 as long as your y1 and x1 are in the same coordinate pair. So give myself a little bit more room here. Let's see here. So I have m is equal to negative 3 minus negative 2 over 1 minus 3. And again, there we go. Here's an example right here of what would have happened if I didn't use my negatives. I might have forgot that that's negative minus, which ends up being a positive. So that is going to be negative 3 plus 2 over 1 minus 3, which is negative 2, and I get here negative 1 over negative 2, which is going to be 1/2. So my slope equals 1/2, and I have y equals 1/2 x plus b. Do some substitution. It doesn't matter which term I use for my x and my y values. So if I replace using that term, I have y is negative 3, and that is equal to 1/2 times 1 plus b. So I have 1/2 plus b over here. I have negative 3 over here. Subtract 1/2 from both sides. And I have b then is equal to negative 3.5, 3.5, or 3.5, or 7/2. So y is equal to 1/2 x plus 7/2. And it never hurts to look real quick when you get done with a problem, and that is y equals 1/2 x minus 7/2. I forgot the minus over here, right? When I moved over here away from my equation, these are all negative numbers. A negative minus a negative is a bigger negative. So there you have. Okay, so when graphing a linear equation, what we want to do is we want to get it into slope-intercept form, which these are in slope-intercept form, and we are going to then start off at my y-intercept and looking at a, y equals negative 2 minus 1. So my y-intercept is going to be 0, negative 1, so I go to 0, negative 1. And I'm going to start there, and what I'm going to do is I'm going to move my slope from that point. And my slope is the same thing as 2. So slope is 2 over 1, my rise over run. So I'm going to go up 2 over 1. And I'm going to start again from that point, and I'm going to go up 2 and over 1. And I'm going to continue to do that to graph my points. Now that's up positive, right? Right positive. That gives me a positive 2, but I can also go down. I can also go left one, which is negative, down to negative, which gives me a positive 1. So there you go. I'm able to continue graphing, and then I'm going to connect those points with a line, and that is going to be y is equal to 2x minus 1, graphed. I'm going to do the same thing on my next equation. I have y equals negative 3x plus 4. Now the slope is negative, so I know it's going to be going that direction. My y-intercept, or b equals 4, so my y-intercept is 0, 4. Right there is my y-intercept. And then my slope is negative 3 over 1. Well, if I go down 3, 1, 2, 3 over 1, down 3, 1, 2, 3 over 1, and I continue to go down 3 over 1, and of course, if you notice, this is half measures there, so I can go ahead and connect these points to see them a little bit more clearly, and there we go. I have graphed from my y-intercept, connected my slope. That is y equals negative 3x plus 4. And in case you're curious, that of course is 4. Continuing on, and I have y equals 4x minus 8, y-intercept right there, so I have 0 minus 8. So it looks like my y-intercept is going to be negative 8 down here. And my slope is going to be 4 over 1, so m equals 4 over 1. So my rise, I'm going up 4, and I'm going over 1. So I'm going to go up 4, 1, 2, 3, 4, over 1, up 4, 1, 2, 3, 4, over 1, 1, 2, 3, 4, over 1, 1, 2, 3, 4, over 1. And there you have it. I can go ahead and connect my dots, points at which I have graphed, and there you have it. There is my y equals 4x minus 8. And if I were to take any one of these points and plug them back into the equation and test them, well, this looks like 4, 8. That looks like the point 4, 8. So if I were to replace y with 8 and then replace x with 4, I would end up getting 8 is equal to 16 minus 8, or 8 is equal to 8. That's a true statement. So yeah, that's the solution. So I was graphing that on mark. That's a way to check it right there. Every point along your graph is a solution to the equation. And last here, modeling a function. So a plumber charges a $65 fee for a repair plus $35 per hour. So the cost is going to be equal to a flat rate of $65 plus $35 per hour, and then writing that equation to model that total cost in y of a repair, which takes x hours. All right, so y is my cost is going to be equal to 35x, because I'm going to replace hours with x, plus 65, because that's a flat rate, which is going to be my starting point, my y-intercept. And now I can go ahead and graph that now that I have an equation. Okay, so graphing this, the best way to do it is just to create a table and find some values to get my input put in and then get out. And I'm going to have 35x plus 65. And let's just start off with when x is 0 hours, my starting point is going to be 35, 0 plus 65. No hours. If they show up and don't do any work, they make a house call, but we don't have them do any job. It looks like it's going to cost $65. Then if we have them work 1 hour, 35 times 1 plus 65 is going to be, gosh, I think it's 100. And then 2 is going to be 35 per hour times 2 plus 65, which should be 135. And then 3 hours is going to be $35 per hour times 3 plus 65 is going to be 170. So there's my graph. I can graph these ordered pairs. In case you didn't realize, the input-output for my ordered pairs. And then I can graph those. I can probably do my slope. So I'm going to start off at 0, 6, 5, somewhere about right there. Go ahead and change colors. I don't know if that's going to be good enough. 100, so 100. 2 at 135, would be about right there. And then 3 is going to be 170, which is about there. So I can go ahead, probably go a little bit higher with that one, and then do a connection of all my lines because it's a continuous rate. And there you go. There you have it. Or it could be a continuous rate. So that graph models the total cost based on the input of hours. And one of the takeaways here is how can you use the slope and the y-intercept of a line to create that graph? Well, you make a point at the y-intercept and then you use the slope to create the second point and then connect those 2 points. And if you have 2 points, you can connect and create a line. 2 points are the minimum number of points necessary to create a line. So again, slope-intercept, most familiar to you. You've been using it for years now, and with a little bit of practice, you should prove proficient.